In today's video, we're going to do something that I've been meaning to do for quite a while, and that is a teardown of the UniFi UDM Pro. I bought this a good few months ago, in fact, probably 6 months, no, more than 6 months ago, and I've been using it as my router ever since. And it's really good. I'm definitely very happy with it. And when I got it, I kept meaning to do a teardown just to see what's inside, how it's all architected, how these switch ports interact with the main CPU and stuff like that. And I've just never got around to it. So finally, I'm going to do that in this video. Additionally, if you're noticing sort of better video quality this time, I've now finally got a new camera. So yep, I've finally gone to 4K 50 with a brand new camera. I'm going to keep what I've gone for a bit secret for now, but in either the next video or the one after, I'll be doing a full video revealing my new camera. So while I'm still struggling to learn how it all works, so forgive me if there's anything a bit dodgy, it should hopefully give me much better video quality. So yeah, here's the UDM Pro. We'll do a quick tour of the outside of it and then we'll take it apart. So on the front you can see you've got a little touchscreen there, a 3.5-inch hard drive bay. That's a SATA hard drive bay designed for if you want to use this as an NVR for UniFi Protect, so you don't have to have a drive in there. 8 gigabit Ethernet ports for the LAN side, a gigabit Ethernet port for the WAN side, and then a pair of 10 gigabit SFP Plus ports, one for WAN, one for LAN. We'll be taking quite a close look at how these 8 switch ports here work, because I've seen a lot of people online getting very confused by this. Because the way this works is you've essentially got a 9-port gigabit switch here, where one of the ports is uplinked to the main CPU at 1 gigabit. So these switch ports will work at full gigabit speed, full duplex to each other. It's got the full 16 gigabit switching capacity. But as soon as that traffic needs to leave these 8 ports and go through the main CPU, either to be routed between VLANs or something like that, or to go between these switch ports and one of the 10 gig ports, then it goes over that 1 gig link which bottlenecks it. So we'll talk about that in more detail later when we're looking at the switch chips. But I just wanted to talk about that now because I've seen a lot of people saying things like this has 1 gigabit switching capacity or a 1 gigabit backplane, which isn't really the correct terminology. And it makes people think this is a lot less capable than it is. So before we open it up, we'll take a quick look around the back. And on the back of it, we can see we have some more ports. So we have an AC input with a standard IC connector. And then over here is an additional DC input for the UniFi RPS. This is designed for the redundant power supply. And it's just, it almost looks like a 24-pin ATX connector, or 20 pins, 24, don't know. But it's designed if you're using the RPS, which is a big external DC power supply. You can connect that into there to then dual feed this from 2 different power supplies. So that's what that is. So now let's take this apart. So first of all we need to do is take off these rack ears. At least I think I've not taken this apart before, because these seem to screw through the top case. So we'll take these rack ears off and then we'll take the sides off, or top off. Okay, so that's the rack ears removed. There's now just a few screws around the sides. So there was also a screw under the rack ears. So yeah, 2 on the sides and then 3 on the back. And unfortunately one of the ones on the back is under like a warranty seal. So yeah, that'll need to come off. But I've had this long enough that I trust it's not going to break or need warranty service. So yeah, time to take this apart. So here we go, this now needs to peel off. I wonder if we can do it in a way that will stick that down again. Nah, I think it's one of those tamper resistant ones. Yep. Oh well, there goes my warranty, but yep. All in the name of science or YouTube. But I've not seen many other teardowns, at least on YouTube, of this, so thought it'd be worth doing. Okay, so now I removed all the screws, and I've just slid the case back a little bit just to make it easier to get off, but I've not peeked inside yet. So hopefully I can just continue to slide this back. Oh, there we go. Oh, that was quick. And it's come off. So there's our first look inside. Now, annoyingly, one of those switch chips is clearly covered with a heatsink that I don't know if I'll get off, but oh well. Let's go in and take a look and see what we've got. Okay, so we're now in. I've gone around inside, I've found some model numbers, looked up some parts, so I've got more information on it. Now, unfortunately, I won't be able to get down as deep as I was hoping, because this chip here has a heatsink sort of thermally cemented onto it, so I can't really take that off without risking damaging it. And then certain parts, like this plastic shroud here, it's almost like epoxied in place in a couple of places. There's like a bit of epoxy here, and then there's also a bit of epoxy on this fan here that's kind of epoxying it to this SFP cage. And while I could probably break all that off and then maybe get this assembly out and take the heatsink off, but I don't really want to do that, because even though I could put it back together and it would work fine. With my network, because I always want to try new things, I quite often change stuff hardware around fairly regularly. So it would be fairly reasonable that I would potentially be replacing this while it's still a usable device. And in that case, I'd be selling it on. And I don't really want to sell something that I've like broken epoxy off, just my conscience of selling something that someone would buy and then find it's been ripped apart. So I'm going to be a bit careful with it. But I have worked out the main CPU in this chip here, so we don't need to worry about that. And I'll show you how I found that information. The overall layout's fairly neat. They seem to have like epoxied in a couple of the connectors as well. Not things like the fan connector, which is good, so you could replace the fan. But things like these board-to-board interconnect, or these cables between the boards and stuff, are epoxied in, which is quite good because you don't want these coming loose. It's a fairly neat layout. You've got a little power supply here, which obviously has AC comes in and then DC out. You've got a little 40mm fan here, I think it's 40mm, and that cools the hard drive. So as far as I'm aware, this doesn't normally run unless there's a hard drive in, and then it turns on to cool the hard drive. I'm not sure if it's potentially based on the hard drive temperature, I think it might be. But yeah, that's there. And it's a 4-pin fan connected to the motherboard, so it obviously has speed control, and also you could obviously replace that with your own fan if you preferred, potentially, if this was too loud. So what I'll now do is we'll go in closer and take a look at some of the components that I've identified. So first of all, we'll start off with this little board over here. And this is where the little touchscreen LCD on the front of the case is. So we go and take a look at this chip. We'll see we have an STM32F205. And this and it also has VG on the end of the model number. That's a sort of particular version of this chip. So it's an STM32F205 VG. And this is just a little STM32 microcontroller. It's the most standard sort of microcontroller you'd use for a purpose like this. In fact, if you'd asked me even before taking this apart what sort of chip I think would be driving that LCD, I would say some sort of STM32. They're just a sort of standard nowadays. But yeah, this little, I think, 120MHz chip, little ARM core, 1MB of flash, and 128KB of RAM. So just a very basic little microcontroller, and that'll provide, will just drive that little LCD. So they can offload some stuff from the main CPU onto this little chip here. And that'll be driving the LCD and dealing with the touchscreen control. Next up, now looking over at the main board, we'll take a look at some of the stuff that isn't necessarily networking related for now, and then we'll go over to networking stuff later. It's a bit more interesting. But we'll start off here with this flash memory. So obviously here you can see the big flash chip, and that is a Toshiba or Kioxia, I think it's Toshiba, Kioxia now own Toshiba's memory division, and it's a THG BMJ G7C1L BAIL. And it's 128GB or 16GB of eMMC flash. So it's just standard eMMC flash storage, and they're using that obviously to store the main OS and the software. Then this chip up next to it here is a GL3224E. And interestingly, this is a USB 3.1 to SD 3.0 adapter. So essentially almost like an SD card reader, basically. So I suspect this is being used as an interface to this eMMC chip from the main CPU. So it's almost as though they're connecting this eMMC to the CPU using USB, which is interesting. Unfortunately, we'll talk about the CPU later. I can't find much information about about the CPU really. I've got a bit of it I've been able to figure out, but I don't know what sort of interfaces it supports in terms of storage. So I don't know if that's maybe the way they have to do it. They have to use USB, which is interesting. Now, interestingly, you've got the SATA hard drive here, but I can't see any sort of SATA controller. You can see these two traces come out here, they go onto the PCB here, that chip's just like a little power management thing, it doesn't do anything important, and then they disappear into the board. So I don't know what they're using for the SATA. So I wonder maybe if the chip has SATA support on board, but not eMMC, but yeah, they've got a little SD 3.0 to USB 3.1 controller there, which I think they're using to drive that eMMC flash. Now another little chip that's quite interesting is down in this corner here. And it's going to be really small to make out on camera, but it's just down here. And you'll see there's also a little antenna connection next to it. And that antenna, flip it round, goes up, and it's located under here. So it's right up under that lip of the case. There's a little tiny antenna under there. And that particular chip, which is now down there because we've been flipping it around, is a CSR8811. And this is a Bluetooth 4.0 adapter, or chip, Bluetooth 4.0 IC. This thing does have Bluetooth, and as far as I'm aware, I never really used it, but it's just for the initial setup. I think you can use the app on your phone to scan for this over Bluetooth, and it helps you identify it and do the very first setup. It's not something I really feel the need for, and but it does have onboard Bluetooth, and that's what's driving it. This supports a whole bunch of different protocols to connect to the upstream CPU. So it supports UART, I2S, SPI, and then PIO and PCM, those two I haven't heard of. So it could be using any of those really to connect to the main CPU, but that's the little Bluetooth controller there. So now with all the sort of additional support circuitry out of the way, we can now look at the actual networking stuff. So as I mentioned, there isn't much information. Well, I can't actually read off of these chips because this has a heatsink cemented to it, and this is all epoxied in, and I'd also rather not mess about with thermal compound under this just to keep it as is, as new. But I've been able to go into the software and figure out what it is. And just in terms of the hardware as well, it's quite nice for cooling. You've got this big heatsink here, which does extend under the fan. You've got this fan here, which is again a 4-pin fan, so that is speed controlled, and it's normally quite quiet. Although I have heard this ramp up if it's, especially if the cabinet's quite hot and it's a hot day, you can sometimes hear this fan going, so it is speed controlled. And what I found quite interesting is they've got the heatsink here, and they've got this big thermal pad on top that seems to just make contact with the upper case. And I can look at the top case and you can see a little sort of smudge on it where this has been making contact. And I suppose that's kind of a nice idea. For the cost of a thermal pad, just stick one on there and just help get some heat from that heatsink onto the top case. And that'll just help get some heat away. And if that stops the fan running, it means the fan can run less, then that's always a good thing. But yeah, so actually in terms of these chips, I went into the software just over SSH, and looking at the output of DMessage, you can see a lot of information about drivers from Annapurna Labs loading. So it says like Annapurna Labs unified 1 gig / 10 gig / 25 gigabit Ethernet driver and things like that. So that shows it's got an Annapurna Labs chip. Now, Annapurna Labs is a company that I hadn't heard of before I got this, and it's an Israeli CPU company that was bought out by Amazon in 2015. So Amazon bought them out, presumably to make chips for Amazon Web Services. And if you look at pictures of these chips, it's a shame I can't get into it, they actually even have the Amazon logo on it. It says like Annapurna Labs, an Amazon company. So it's actually got the Amazon logo on the chip. So it's a chip from them. And then going on the UniFi website, they don't say what chip it has, but they mention this has 4 ARM Cortex-A57 cores, and they're 1.7 gigahertz. Then if you look on the Wikipedia page for Annapurna Labs, because there's really little information about them at all, you can see a list of their different chips, and only one of them mentions that it has 8 ARM Cortex-A57 cores, and that's the AL324. So that's what this has. It has an Annapurna Labs AL324 CPU. After I found all that out, I was able to then confirm it by finding the FCC teardown photos, which do show an AL324 chip. At the time that this was new, there wasn't much information about that chip at all. However, now since it's been out a bit longer, a bunch of other devices have come out using that chip, including some QNAP NASes and the MikroTik CCR2004 router. And it seems like a really versatile chip in terms of network interfaces, because different devices seem to have all sorts of different network interfaces running off this chip. So, going to be on a bit of a tangent, but looking at the MikroTik CCR2004, which is one of their high-end routers, really want one to try out at some point, they have 2 different versions of that. They have one that has a bunch of 10 gig SFP plus ports, and it also has, I think, 2 25 gig QSFP plus ports, and they've also got another version of the same router, but instead of all the SFP plus ports, it has, I think, 16 1 gigabit Ethernet ports and a pair of SFP plus ports. Now, what's good with MikroTik is they actually show block diagrams of all their routers, so you can see how they're all laid out internally. Both of those routers use the AL324 chip, but on the model with the all the SFP plus ports, it shows the chip connecting to what they call a port extender using 2 25 gig links, and then it shows a separate 1 gigabit interface coming off the CPU for management. So that shows it can kind of do 2 25 gig interfaces and 1 gig simultaneously. But then on the model with the RJ45 ports, it shows that they have 2 1 gig switch chips that are uplinked at 10 gig, and then the 2 SFP plus ports are uplinked at 10 gig. So on that model, the CPU is driving 4 10 gig interfaces. So it's just kind of interesting to see all different interfaces that can drive. Now, of course, in this system here, what we have is two 10 gig interfaces coming off of it, a 1 gig interface for the WAN, and a 1 gig interface to this switch chip we'll talk about next. So in this situation, it's running two 10 gig and two 1 gig, but it shows it can actually potentially do more than that. You know, it could actually run four 10 gig interfaces. Ultimately, it just comes down to the cost. And I suspect there might also be limitations around running pairs of interfaces at the same speed and stuff like that, so it maybe impacts the flexibility of what they can do here. But yeah, that's the CPU. And then while I've alluded to it a few times, we've now got this mystery switch chip under here. And this is that thing that definitely confuses a lot of people and makes people think this is like a switch with 1 gigabit of switching capacity and all that nonsense. What this is a Realtek RTL8370MB switch chip. And I was able to find that out again just by looking through the D-message output and just seeing that driver load and seeing what model that switch was. And that's an 8-port 1 gigabit Ethernet chip, switch chip. It's a layer 2 managed switch, so it supports VLANs and all that sort of stuff. There's nothing special about this, but there's also nothing super terrible about this. It's just an 8-port managed switch chip with 8 1 gigabit Ethernet interfaces. That has the 1 gig PHYs built in for those ports, and then additionally has two additional interfaces, which I'm going to get the terminology wrong here, but they're basically additional interfaces for uplinking to external PHYs. So they support different protocols: MII, TMII, RMII, SGMII, 1000 base X, and 100 base FX. So you'd use that to connect to like an external SFP port or external transceivers, external PHYs that convert the switch to a physical interface. So that's what they'll be using to uplink to the main CPU. They'll be using one of those extra two interfaces, using one of those protocols I mentioned to uplink that to the main CPU at gigabit. And this is where people get confused. What you've got here is essentially a 9-port switch where one of them plugs into the CPU at gigabit. It's no different to taking a little UniFi switch and plugging it into this over gigabit. So if you've got traffic just passing around on this switch, then it'll be able to do full 16 gigabit switching capacity. You could run all the ports talking to each other at full speed simultaneously, and that would be fine. There's none of this 1 gigabit switching capacity or 1 gigabit backplane people keep talking about. But all it means is that any traffic from this switch that needs to go through the CPU will be limited to gigabit. So that's if you've got, say, routing between VLANs, that'll have to go through this CPU. But also if you're going from these ports to the 10 gig port, the 10 gig LAN port, again, that goes through the CPU over this 1 gigabit link. So that's the main limitation you would find. It's not like you've got an 8-port switch, which also has a built-in 10 gig interface, where the 10 gig interface can talk to all these ports and it's a 10 gig interface on the switch. You do have that limitation where anything going between this and the CPU or the 10 gig LAN interface will go over that 1 gig link. So yeah, when people keep talking about 1 gig switching capacity or 1 gig backplane, it's not. It's a 1 gig uplink would be the terminology you'd want to use there. But yeah, other than that, it's just a fairly standard 1 gig switch chip. Really nothing complicated or special at all. So that's most of the networking there. The only other chip is this little Atheros one down here, which we'll go into. And this is an Atheros AR8033AL1A. And this is just a 1 gigabit Ethernet PHY. So this is also going to be connecting into the main CPU. The CPU mustn't have built-in PHYs, so that'll handle all the physical layer stuff to interface with this RJ45 port for the WAN. So that's what that's doing there. It's quite interesting just seeing how it's all working, but yeah, that's all that does there. That's basically all the main chips. A couple other things I've sort of looked into but weren't really exciting were these two chips over here. These are VHC595. As far as I can tell, they just seem to be 8-bit shift registers. There's two of them, and I suspect it's maybe something to do with this bus communication over this interface here to that touchscreen board. I'm not quite sure. There's this little header here, which is interesting, because it's got 4 pins, and it's GTR are the labels on those pins. So I wonder if that's some sort of maybe programming header, maybe how they write to this flash potentially. I'm not 100% sure on that. And then there's this CAN here, which unfortunately I'm not going to take off obviously. And I went on the FCC teardown photos, and I can see that under here there's a crystal oscillator and a national semiconductor chip with a part number of 51CD81G3. But I can't find any information on that chip at all. It just doesn't seem to exist. So I have no idea what that does. I don't know if it's some sort of clock thing or what, but yeah, that's under there. But I don't know what that does. But yeah, that's a look at all the main parts inside this. And it's been a pretty interesting teardown. It was a shame I couldn't really get into the main CPU and take this off, but I just don't want to risk damaging this because A, it's my router, and B, I want to kind of preserve its resale value. But it's been quite cool to take apart, and it's good just to dig in and just work out exactly how the network interfaces on these work. Because it's interesting with UniFi, they're quite vague with things like that, so you're buying this and you don't necessarily know how all the network interfaces operate together and what things uplink to what and what speeds there are involved. And that's why people get confused and you end up with all this misinformation. Which was an interesting contrast with, say, Microtech with when I was looking at that CPU with their CCRs, where they actually show a block diagram that actually describes how all the different chips are connected, which does spoil the surprise of taking it apart, but it does make it a bit clearer as to how all the interfaces work together so you can kind of design your network around it. But yeah, it's been a pretty interesting thing to take apart, and as a sort of very brief sort of long-term review of it, I'm very happy with it. The software is definitely a bit more limited than, say, going for an edge router or a Microtech or PF sensor, all those sorts of options. You kind of need to work with the software you've got, and you can find limitations of like terminating VPN tunnels or doing more advanced routing. But if someone's ever coming to me saying, right, I want a home network, I want it to be sort of very reliable, very fast, but if that person's not a technical person or not some sort of network engineer, they just want a decent home network, this can be a very good device because you can kind of set it up with all the other UniFi devices. They can manage it on their phone, and it's not really any harder to manage than a little TP-Link router. Whereas if you were to go all in and throw in higher-end enterprise networking kit, you're going to be constantly having to support them with it. So, yep, for the certain use case, this has been a very good device. And yeah, it's been perfectly stable. I've never had it crash, I don't think. So yeah, I'm definitely very happy with it. So yeah, now time to get this all put back together and get my network back on because I've currently been stuck offline, which meant Googling all those part numbers. I'm literally hanging out the window with my phone trying to get a phone signal so I could look it all up. So it'd be nice to get my internet connection back. So yeah, time to get this back together and hope I've not broken it. So that was a quick teardown of the UDM Pro. And it was pretty interesting to see inside, just to see A, how it was all built, and B, see how all those network components interconnect and how things are uplinked to each other. It was a shame that I couldn't get down to a couple of the bare chips, but at least digging through software I was able to work out what they were, so that was absolutely fine. So yeah, thank you very much for watching, and if you're interested in buying a UDM Pro, there's links in the description.